Hello, my name is Tamanna Chaudhary, and the topic of our today's discussion is applications of back bonding, a very important concept when we are dealing with AIMS exam or NEET exam, which is itself a subcontext of AIMS exam. Let us start. Now, with the help of back bonding, we can know that which molecule is more stable. Now, the concept we will be applying is that a molecule with back bonding is more stable than molecule without back bonding. Now let it be this way, that there are two walls. Imagine in your heads that there are two walls and both are made up of bricks, okay, and we are applying cement to one of them and not to the another one. So which among these two walls is going to be more strong? Obviously the one we are applying cement to. सो बैक बॉन्डिंग का कंसेप्ट सेम वे में वर्क करता है, क्योंकि बैक बॉन्डिंग है क्या? इट इज़ जस्ट अ प्रॉपर्टी अ मॉलिक्यूल कैन पोजेस जो उसको ज़्यादा स्टेबिलिटी प्रोवाइड करे. तो जितने ज़्यादा जब हम दो मॉलिक्यूल्स को के साथ डील करते हैं जिसमें बैक बॉन्डिंग दोनों में प्रेजेंट है, देन द मॉलिक्यूल विथ स्ट्रॉन्गर बैक बॉन्डिंग विल बी मोर स्टेबल. Get it? Now this is the order of stability, three type of which includes three type of back bonds that are possible, and 2p is like the Amitabh Bachchan of back bonding. जहाँ ये खड़ा हो जाए लाइन बस वहीं से शुरू होती है. Why? Because 2p is the most stable type of back bond because it is the most strongest one, followed by this and then this. Let us look at a few examples to let this concept get into our heads. Now taking the example of CCl3 positive and CF3 positive. Now in both of them back bonding is present. Why? Because both have lone pairs to donate and both have lone pairs to accept. How? Because they both have empty p orbitals. Now here 2p pi 3p pi bonding is present, and here 2p pi. Why? Because here we are dealing with chlorine and valence shell इसका कौन सा है? 3p. So 2p pi 3p pi and fluorine 2p pi. Now as I told earlier, 2p pi is the strongest, thus this will be more stable. Moving further to another example, here the molecule, what is the difference between these two structures? यहाँ पर CH3 है and यहाँ पर silicon H3 है. Now both have electrons to donate obviously, but do CH3 have any empty p orbital to accept this lone pair? No. Silicon has empty 3p orbital to accept this lone pair. So back bonding is present here of what type? 3p pi 2p pi. Thus this is more stable because of back bonding. Now another concept we can apply back bonding to is when we need to find that which of the acid is better acids. Now when we are given two acids and we need to compare the acidic strength of both of them, make their conjugate bases. Now what actually are conjugate bases? Conjugate bases are the structures found when we remove a proton from an acid. For example, when we take two acids CHCl3 and CHF3, we make their conjugate bases. Remove a proton, CCl3 negative and CF3 negative. Here are the structures of both of them. Now second is weaker the conjugate base, more stronger is the acid. So जितना ही conjugate base weaker होगा उतना ही ये stronger होगा. Now let us see that which among them is the weakest, so we can decide which among them is the strongest. Now here back bonding is present. How? Because it has electron to donate and it has empty p orbital to accept. Now here empty this has electron to donate, but does it have any p orbital to accept? No. So back bonding is not present, thus this is weaker. So when I say this conjugate base is weaker, I mean to say that this acid is stronger. Clear? Let us move further. Now we can apply the concept of BB, that is back bonding, to explain the exceptions in hybridization. The concept, what is the concept we will be applying? That due to back bonding, sometimes the molecule hybridizes to lower edge. What do I mean when I say that the molecule hybridizes to lower edge? Now, in the last video, I told you how to find H, which is the hybridization number, which in case of sp3 is 4, in case of sp2 is 3, and in case of sp is 2. And now I mean to say that when back bonding occurs, then the molecule showing sp3 will show sp2, and the molecule showing sp2 will show sp. Oh, wait for a second. Yeah, here will show sp. Now taking this example, now both have lone pairs to donate, right? And here, do we have any empty p orbital to accept this lone pair? No, so back bonding doesn't occur, and it shows regular sp3 hybridization, which it is supposed to show. Now here, nitrogen has electron pair to donate, but does silicon H3 has any empty p orbital to accept the lone pair? Of course it is present. 3p orbital is present in Si, which can accept the lone pair which the nitrogen want to give. So back bonding is obviously occurring, so it will show sp2. But if back bonding was not present, this molecule would have shown sp3 hybridization. But due to the presence of back bonding, now it is showing sp2 hybridization. So are you getting the concept that the molecules which are supposed to show sp3 will show sp2, and sp2 molecules will show sp? I hope I have made myself clear. Now moving to the last concept, not last concept, obviously back bonding has a vast array of concepts, but only the important concepts that we need to do to crack AIIMS exam this is the last concept. I have mentioned what is this happening today? I have explained every other concept that we need to do, and this is the last one among them. And it is based on the concept that stronger the back bonding, stronger is the bond length. Now this is no news to us. We obviously know that जितनी ज़्यादा back bonding होगी उतनी ही short bond length होगी. अब let us learn it this way कि जब दो atoms में triple bond होती है, स्ट्रॉन्गर बॉन्ड होती है, तो बॉन्ड लेंथ छोटी होती है. फिर डबल बॉन्ड आती है तो बॉन्ड लेंथ थोड़ी और बढ़ जाती है, एंड सिंगल बॉन्ड लेंथ आती है तब और बढ़ जाती है. तो उस कंसेप्ट को हम इधर लगा रहे हैं कि जितनी ज़्यादा स्ट्रॉन्गर बैक बॉन्ड होंगी उतनी ही छोटी बॉन्ड लेंथ होगी. नाउ हम इन 3 एग्जाम्पल्स को देख के हम इनको कंपेयर करते हैं. नाउ फर्स्ट एनालाइजिंग दिस एग्जाम्पल, this is iodine and these 3 atoms of chlorine are bonded with it. Now neither of them belong to second group, so back bonding is absent, obviously, because the one of the conditions which need to be fulfilled in order to show back bond is that one of them need to be of second group, but neither of them belongs to second group. So हम इसको पहले ही कैंसिल कर देंगे कि भैया इसमें बैक बॉन्डिंग हो ही नहीं सकती. Now moving to this example, boron has empty p orbital to accept lone pair, chlorine has lone pair to donate. तो बैक बॉन्ड फॉर्मेशन होगा which would be of 2p pi 3p pi nature. Here fluorine has lone pair to donate, boron has p orbital to accept. यहाँ पर भी बैक बॉन्डिंग होगा, लेकिन नेचर ऑफ बोथ ऑफ द बैक बॉन्ड्स formed in these 2 molecules is different. Here 2p pi 3p pi back bond is present, and here 2p pi back bond is present. Now as I said earlier that this is the most strongest, so this being the most strongest will show the shortest bond length. फिर ये थोड़ी सी बॉन्ड इसमें बैक बॉन्डिंग है तो ये भी छोटी बॉन्ड लेंथ शो करेगा, लेकिन इससे ज़्यादा बड़ी शो करेगा. आई हैव नो आइडिया व्हाई दिस इज हैपनिंग. एंड इसमें बैक बॉन्डिंग है ही नहीं, तो ये सबसे ज़्यादा बॉन्ड लेंथ शो करेगा. आई होप आई एम वेरी क्लियर विद इट. These are the concept. Write it down in a page एंड दीज आर सम वेरी वेरी इंपॉर्टेंट कंसेप्ट जो बहुत ज़्यादा सीधे वे में आएंगे. लाइक इन एम्स एंड नीट एग्जाम वी आर नीड टू फाइंड दैट इनमें से बेटर एसेट बताओ. सो सिंपल कंसेप्ट है बैक बॉन्ड एंड वी विल बी able to answer to multiple questions. Thank you very much. I hope I have made this video very clear to all of you. Thank you so much.